before I begin, this is work done in complete collaboration with Dan Rokny. Actually, it could have been him talking now, but it turns out to be me. And the other thing is that you can see the title of the talk. It's Studying the Behavioral and Neuronal Consequences of Stimulus-Drug Association. And the stress is on the studying, meaning that we're still in the process of doing this. And what I'm telling you is very preliminary work and our first steps in this direction of addiction-related research. Both of us study olfaction in various ways. But despite the fact that we're not in the field, maybe there's something that I can tell you that you don't all know about addiction, and that is that many times when people smuggle cocaine, they hide it under crates of bananas. Is this a well-known thing? I don't know. And when Danny and I heard about this, we were very concerned because we thought, what happens if the smell of bananas gets and remains on the cocaine, and then people who use the cocaine smell a banana, and then later they may associate the smell of bananas with cocaine. And that could lead them, every time they smell a banana, to have a very strong craving for cocaine. And that's not a good thing. And that's what we wanted to study, okay? This is this process. More generally and more seriously, it's a very good thing to be able to associate environmental cues with certain outcomes. And in particular, odors, that is smells, they have a very strong, or potentially a very strong effect on eliciting emotional and motivational states, just like in this example that you see right here. And that's, as I said, it's a good thing. It lets us learn about our environment. But sometimes the outcomes can be, or when the outcomes are very salient, either positive or negative, this may be, or this association may be a bad thing. And one extreme is when you have a very aversive stimulus, and that could lead to a reaction like PTSD, where a cue that is actually not really indicative of danger can become something very threatening. And the other direction is when there is a cue that's very rewarding but not actually beneficial. When a stimulus is associated with that, that could also cause behavior like addictive behavior, which is detrimental. So these associations are not necessarily a good thing, and we wanted to study this. And so here's a very, very simplistic model where we have stimuli. You see 5 different stimuli. Think of them as olfactory stimuli. And we have sensory representations in the brain, and there is a link between the representations and the stimuli. Okay, it's a very simple one-to-one mapping just to show to illustrate the idea. And then we have a drug stimulus, and this drug stimulus is also paired with one of the odors, one of the odor stimuli that we have in the world, for example, the smell of a banana. And the consequences of this these are our hypothesis, is first of all that this association will promote drug-seeking behavior once there's presentation of the paired stimulus. PS stands for paired stimulus. So this is this error right here. But that's not all. We also predict that this kind of exposure will make the system or the organism more sensitive to that stimulus, okay, and elicit a stronger neuronal response to that stimulus, which could also strengthen the link between stimulus exposure and drug-seeking behavior. And furthermore, and this is a little bit more subtle, but we also speculate that this might change the way that stimuli are mapped, and that maybe stimuli that were initially clearly distinct from that associated, from the paired stimuli, will seem to be more similar and could also cause this type of craving. Okay, so this will increase the range of stimuli in the world that could elicit craving, and all of these things are negative things in the sense that they could cause, or they would increase the chances for relapse, make it more difficult to avoid drug withdrawal. So our goals in this project were, first of all, to establish a mouse model of what we called stimulus-drug association, SDA, and to do it using olfaction. And then we said if this would work, then we could test whether this changes the way that the stimuli are perceived. And if that happens as well, then we could test how this changes neuronal representations, okay, how these stimuli are mapped in different ways. And then eventually, maybe we could identify mechanisms that are involved in these associations and maybe find gentle ways to break this association. And hearing the talks, I realized that, this is a very naive first look at something that people have been thinking about, people like you have been thinking about for a long time. And all the work that I will describe now has been done by a very talented PhD student in the lab, Judith Levy, who's sitting here. And she was working with an undergrad in the lab, Shiran Berko, who's not sitting here. She's not here right now. So let me tell you first about the first step to establish a model for SDA. So what we do is something that has already been described by Rami and by Yoni. So nevertheless, I will say it. We're doing CPP, condition place preference, and we inject the cocaine, and then we place the mouse in one side of the chamber. And of course, the chambers are distinct for the mice, so they can identify them. And then we also do we balance this by also injecting saline in the other chamber, okay, just to make sure that it's not just an effect of the injection itself. And CPP means, of course, that the mouse will show a preference to the injected site even when there's no cocaine. And CPP is only one part of the story in our case, because we also want to introduce the element of the odor, the stimulus-drug association. So in our case, the stimulus is some smell. It's actually not a banana smell. But we also pair in some of the trials the drug delivery with the odor, and we ask whether exposure to the odor in a neutral setting prior to testing in the CPP will increase the drug-seeking behavior. Okay, this is a critical question that we want to ask and establish a model for. And this is a little bit more detail. So this is a pretty short sequence of the experiment. So we have 9 days. On the first day, the mouse is habituated. And then over 4 days, the mice receive the cocaine or the saline with the paired or the non-paired side. Then there are 2 days of abstinence over the weekend, and then we test them. And the critical thing when we test the CPP is we either do it just regularly without any pre-exposure to an odor, or we give them 2 minutes of exposure to the odor that they received before, but this is done in a separate chamber, okay, not inside the CPP chamber, and then we test them, okay? So it's as if you were presented with some smell of banana regardless of any drug context, and then we ask, what is your craving for the drug at this moment? And Yoni already showed the formula. So clearly it's a measure that ranges between -1 and 1, where 1 means that the mouse spends all the time in the site where the drug was given. So this is the results of the conditioning. In this case, we have 9 different mice, 6 from one strain of mice, C57, 3 from another strain, the bulb C strain that we actually decided not to work with. And what you see here is one line, each line is one mouse, and there are 2 data points, one without the smell and one with the smell. I should say that the order of the days that we gave the smell or did not give the smell before was randomized, okay? So it's not just a temporal effect. But here they're organized according to whether they received the smell before, which is on the right side, or they did not receive it before, which is what you see on the left side. So a little bit of statistics. One test is whether overall we actually were able to induce CPP. And when we look at all of the different data points, we ask how many of them are below, or to what extent actually they are below 0, or they're positive, meaning that there is a preference. And indeed, this is a significant effect. But the more important question for us is whether there is a trend of pre-exposure to the odor strengthening the CPP. And this is a paired test that we do, a paired rank sum test, and indeed we see a significant effect, meaning that getting this type of trend over all of these mice, almost all of these mice, is not something that you would likely see by chance. So we do think that we do need more repetitions and we do need more controls, but we think that we have a pretty good model for for showing that a brief exposure of a paired odor can increase the drug-seeking behavior. So we continue to the next stage, which is to start to ask about how the mice perceive the odors. And to do this, we use a lick-no-lick paradigm, which I think has not been really described in this conference. And so we have a mouse, and the mouse can either lick or not lick. So there are some stimuli that do not provide liquid reward to the mice, and mice typically learn to stop licking in response to such stimuli. And our stimulus set is, we have 8 different stimuli, and these are mixtures, okay? So this is just a table showing you the mixture. So we have 2 odors, 2 odorants, and we play with their fractions. So either we have the pure odor ethyl propionate, although it doesn't matter the identity so much. So the pure don't lick odor, and we have the pure lick odor, and then we have a series that morphs from one to the other, okay? And what you see in the bottom row is what the mouse should do in order to perform the task optimally. And this is just to show you what would be the ideal behavior of the mouse in this type of plot where we show, okay, and in this type of plot what I show you is the go odor concentration. Okay, so the concentration of this odor over here, and this is the fraction licking, because the mice do this many times, so we look at the fraction. So that would be an ideal behavior. They really always can tell which odor has the higher concentration, and this is the type of response that one usually sees. It's a more gradual response. It's not perfectly binary. Of course, the mice also, they make mistakes, so we're looking at the average performance here. Now, what would we expect following the stimulus-drug association? So our prediction is that after, and this is important, I should say it, when we do the pairing, in this case, we pair the drug with the go odor, okay? And our prediction is that this would make the go odor more salient or more stronger at any given concentration in the way that the mouse perceives it. And so what we predict is that the curve, if the black line shows the baseline curve, okay, this is the concentration of the go odor, we would predict that everything would shift to the left, okay? Or maybe go up. You can see it in both ways in a way. But it would mean that at any given concentration of the go odor, the mouse is more likely to lick. Okay. So how does the data actually look before and after the stimulus-drug association? Before I show you, I just want to clarify that what I will show you now is a graph that we fitted to the data. The actual data looks something like this, which means it's a little bit more noisy, and we have only 8 data points. We don't have a continuous graph, right, because we're not testing over all possible concentrations. And so we're fitting these logistic curves, which have 3 different parameters. And this is useful not just for graphical purposes, but it also allows us to make quantitative statements about changes in these figures as a function, and this behavior as a function of the stimulus-drug association. So here are the results. Rami said that he doesn't jump to conclusions based on 4 mice. And now we'll have to jump to conclusions now based on 2 mice. But these are very, very good mice that I'm basing the conclusions on, namely mouse A and mouse C. And in both cases, you can see the baseline in blue, and you see the behavior after SDA in this orange-red. And you can see that generally there is indeed a shift to the left or upwards. Okay, so this is not perfectly, also the baseline graphs are not perfectly like we would predict based on ideal optimal behavior, but the trends that we see are consistent with the idea that pairing a drug with, or pairing an odor with a drug makes the mice more sensitive to that odor. I will actually summarize now. It's a first for me actually not to run out of time. I'm not sure if it's a good thing, but here I am. So we're working on a mouse model of SDA using olfaction. We do need more controls that look for odor specificity and some other effects. We need also more mice. And we think that SDA changes stimulus perception, as we have shown here. Again, more controls are needed here for the specificity, so this is something that we're intending to do. And our next stages would be to test how this changes neuronal representations. And we also have tools. There's some interesting brain regions that Danny has discovered that could play a role in these associations, and we could manipulate them to see how this affects both the behavior and the perception. And another direction of thinking about this is to find friendly ways that we can, just like very similar to the ideas that were raised here before, in which we can stop the link between the stimulus, the banana, and the cocaine, so that people can enjoy their bananas again without having to worry about relapse. So, and I do want to thank, sincerely thank, some people. First of all, Yoni and his lab, who we had no idea about CPP and how to do this, and Yoni gave us cocaine. He was very nice to us in this way. So really, we wouldn't have done this without them, and it's in this sense, it's a collaboration as well. I want to thank Karen Marom from my lab, and I want to thank iCare, who gave us seed money for this project, and also the ICAM. ICAM-H, you say, or ICAM? ICAM, who gave a PhD scholarship for Judith Levy. And I think it's really, I'm really thankful to the fact that this, we want to get money. So this pushed us in the direction of thinking about how our research can interact, or how it's relevant to drug or addiction research. And I think that this thinking about this really pushed us into a direction that we wouldn't have done without this opportunity. And it's a combination of something that is hopefully applicable and medical oriented, but also basic research, which I speak for myself, but I think also for Danny, it's not a compromise of basic research, and it's really great that you can do something like this. So I really think it's in that sense, this is a great initiative pushing people to do these things. So that's it. Thank you very much.